Okay, everybody, this is a experiment, so hopefully this works out well. I apologize if maybe some of the stuff doesn't work so great here on this first video. I'm doing this with the new book, so bear with me. Okay, I'm probably going to have you copy the screen, and then I'll have to clear it and scroll it just kind of like I have to do in class. Okay, so do your best today, and we'll kind of see how it goes. First thing that we're going to look at today is the vocab is pretty straightforward. We're going to have inductive reasoning, which means I can look at patterns and kind of predict what might happen next. A conjecture is a hypothesis, so that's my prediction. And then we're going to look at counter examples. That's going to be when I can prove that something's false. We'll learn that's going to be kind of a big thing as we go through this chapter. Okay. So if we move on here, I'm going to have you guys go ahead and highlight in your notes inductive reasoning. So I'll underline it. And that's based on a process of reaching a conclusion. And I'm basing that on a pattern of examples. Okay. We can make use of inductive reasoning to make an educated guess based on knowing some information. Okay. This educated guess is also known as a conjecture. Okay. So a couple different ways that we're going to look at this. They might call this algebraically and geometrically. So the first example we have here, it looks like I got to go to the doctor's office, and they make their appointments to last for about 45 minutes so the doctor can look at you, do whatever they need to do, and then have time to answer questions you might have. So they've kind of made their day into 45-minute increments. And so if the first appointment starts at 8:30, then we kind of go on and on. We've got a pattern going on of the times that are available. So the first thing they're asking us to do is down here at the bottom, each appointment time is 45 minutes after the previous appointment time. The next appointment time is at 10:45. That's what they gave us at the end. So predicting it, what would the next appointment time be? And so if we add 45 minutes on to 10:45, we get 11:30 a.m. Okay. So looking at a pattern and then kind of getting what is the pattern, and then being able to make a guess of what the next, in this case, appointment should be. Okay. Taking a look at this pattern here, we're looking at 1/2 and 1, 2, and 4, and we're trying to figure out what would the next sequence be. And so we need to figure out, well, what is the sequence? So if we look at this, kind of think about it, what's happening to each number as it increases, obviously. And if you think about it two ways, you might want to say it. It looks like I'm doubling each number. Or multiplying by 2. So either way, you might say that. So that looks like that's what the sequence is and the pattern that I can kind of figure out. And so the next number in this sequence would probably be, if this is 4, I'm doubling everything, this must be 8, okay? On a test or a quiz, though, I wouldn't ask you just for one number. I'd probably ask you for the next like 2 or 3 numbers. So let's kind of do that. The next number after 8 would be 16. The next number after that might be 32, and so on. Okay, so something you just kind of have to make sure you read. It's not typically not just going to be one answer on kind of one couple. All right. Okay. If we go ahead and take a look at another algebraic example, the conjecture here, and we've got to make sure we understand it, is the sum of 2 squares that are consecutive natural numbers. So remember, consecutive means they come one after each other. So like 1 and 2 in this first example are natural numbers, and they're consecutive, but I'm squaring both of them, and I'm going to add them together. So 1 squared is 1, 2 squared is 4, 1 plus 4 gives me 5. Okay. The next set of numbers I look at is right below that. 2 and 3 are consecutive. 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. That goes there. My next one up at the top, 6 and 7 are consecutive numbers. 6 squared is 36, 7 squared is 49. 36 plus 49 gives me 85. 10 and 11 are consecutive numbers. 10 squared is 100. 11 squared is 121. So I think I get 221. Okay. So we've done kind of what they've asked us to do, but now we got to be able to come up with some kind of conjecture about these numbers. So someone in last class said, hey, they're just getting bigger. Okay, well, that's great, but you know, I need something a little bit better to classify that. So if you look at all 4 of these answers, yeah, they're getting bigger, but what kind of numbers are they? So if you look at them carefully, those are all odd numbers. So the conjecture would be that I'd have to kind of repeat some of what they gave me. The sum, and you're going to have to do this. I think they do this down here below, but we're going to have to learn how to write these. So let's just write this in our own handwriting. The sum of 2 squares, and I'm abbreviating, sorry about that. The sum of 2 squares of 2 consecutive numbers, so that's kind of important, is always odd. Or something like saying there are going to be odd numbers or natural odd numbers, something like that. Okay. So they kind of did it for you down here, but we have to learn how to write it. So if we put it in our own words, hopefully we'll look at it and recognize it. Okay. This chapter, I kind of call it like the law degree of geometry. We're learning about specific rules that allows us to do stuff in math. And there's going to be lots of writing with it, so it can be like English in math class. Okay. All right. You got all that written down. I'll give you a moment to get caught up, and then I'll have to erase it. Okay, this next one, kind of similar, but a little bit different. The sum of 2 odd numbers is always a blank number. So let's just, I'm going to throw some out to you. The other class, we kind of threw them out. But if I took like 1 and 5, those are both odd numbers. I'm getting the sum of it, it's 6. I took 3 and 9. And that gave me 12. We took 7 and 21. That gave me 28. And then one more, we took 11 and 35. That gave me 46. So if you take a look at that, when I add 2 odd numbers together, what kind of answer am I getting all the time? And if you look at the answers and kind of find a common thread there, they're all even numbers, okay? So when you add 2 odd numbers together, they didn't have to be consecutive, kind of like the other one. Then I can go ahead and say, hey, I'm going to get an even number answer all the time. Okay? All right. I did skip a couple of examples here because I want to make sure I'm not wasting your time, my time, trying to make this recording work. So just kind of do what I'm doing, okay? And I think I got to go to the next page. Okay, this is geometric inductive reasoning, okay? So we're looking at some geometry stuff. First off, these are called isosceles trapezoids. And isosceles means that 2 or more sides are congruent. Okay, so that's what the hash marks are doing here on these. Okay, you can, I hope that you can obviously tell that these are not all the same size trapezoids, but in each one, each of the sides are going to be equal. And in trapezoids, something you'll learn again, but I'm just going to mention it now, these bases are going to be parallel to each other. So we use these little arrows to show that lines are parallel. So if the lines are parallel and the sides are congruent, the question is, or the conjecture I can make, what can you say about the diagonals in each of these trapezoids? So with kind of that, we can make an assumption that, and if you write this down, I know they did it down here, but in isosceles trapezoids, and these are these lines, the dotted lines are called diagonals. The diagonals, the diagonals are congruent. Okay, so that would work for all three pictures there. Doesn't matter that they're congruent to each other from trapezoid to trapezoid, just the diagonals inside of it are going to be congruent to each other. Okay, so that's using geometry to help make conjectures using some of the rules in geometric figures. Okay, let's go here. Okay, we're going to make a conjecture here. Let's draw a line. We got AD. C is the midpoint of AB, so let's draw that. And D is the midpoint of AC. Okay. So they're asking here in my conjecture, what can I kind of determine? AD is what of AB? Okay, so knowing that C is a midpoint is kind of important. Knowing that D is a midpoint is kind of important. So I think, let's see if you guys can get this one. I think that AD is 1/4 of AB. Okay, the length of AB. Okay. All right, down here in this table, now we're looking at tables or sets of data to be able to make a conjecture. So we're taking a look at gas prices from 2010 to 2018. So if you look at the gas prices there, at a certain point, starting in 2010, they start increasing every year. Then at a certain point, I believe 2013, they start to go down. And then I believe starting in 2016, they start to go up, or actually 2017, they start to go up. So we're looking at kind of a fluidity here. They're going up and down over periods of time. And you guys have probably seen that lately with our gas prices. But they want to know, can we make a conjecture about the gas prices in 2019? So I believe if we kind of think about that, from 2017 to 2018, it went up 42 cents. And from 2016 to 2017, it went up 28 cents. Okay. So I think we can make a conjecture. You can disagree with me, but gas prices will increase in 2019. Okay. So they use a fancy word down here called oscillating. That means it's kind of doing different things over a period of time. Okay. All right. Hopefully that was kind of understandable for you. And then we're going to go here. Hearing loss. So we have this scientific study looking at hearing loss of people between the ages of 12 and 35. And we're looking at the level of music that they're listening to, especially when they have earbuds in, okay? And the studies show that you have some ear loss or hearing damage based on how loud your music is, and also how much time you're listening to it. So it's not just how loud it is, but the duration of time you're spending doing that. So they have decibel levels over here, and they have exposure time on the right, and they want to know what kind of hearing damage might occur at 106 decibels. So, you know, if you're like me, if I hear AC/DC come on while I'm listening to the radio while I'm driving the car, you know, I crank it all the way up. So I don't know if it's at 106 or not, but I'm getting hearing loss for the time that AC/DC song's on, okay? So if you look at this, the last number here on the left-hand side is 100, and if you look at these, they're increasing by 3 each time. So what would the damage be at 103 decibels? And if you look at the exposure time over here, this is in hours. So if you look at it, I think you're looking at the hours are decreasing in half each time. So 1/2 of 1/4 is 1/8. And then if we go to the next decibel level, adding 3, I get to that 106 that they're talking about. And 1/2 of 1/8 is 1/16. Okay. Now remember, this was done in hours. So I'm going to take the number of minutes in hours, because they want to know how much time it would take us at 106 decibels to start experiencing hearing loss or damage. So I'm going to divide that by 16, and that gives me 3.75. Okay, and 0.75 of a minute is about 3 minutes 45 seconds. So hopefully my AC/DC song doesn't go that long and I won't have any hearing loss. Okay. Oops. Let's see if I can actually write a little bit neater than that. There we go. Okay. So kind of a cool thing. Science really is true, so we got to make sure we're listening to that. Okay. All right. Okay, got to the end. No, I got one more here. A couple more here. Okay. In example 5, they're asking if n is a real number. So, you know, like all the positive whole numbers, all the negative whole numbers, 0. If n is a real number, then negative n is a negative number. Okay, now what they did was, okay, well, if n could be any real number, let's pick -4. And if I put -4 in here, which would look like this, well, what happens when I have 2 negatives? It's going to change it to positive. Okay, so that's not true. So when I can use something to prove something's not true or it's false, that's called a counterexample, okay? And if you could write this down, please, and highlight it. We need only one counterexample to prove a conjecture false. Okay, so like in science, you create a hypothesis about something that might happen out there in nature. You create the hypothesis, but then you got to set up a test, and then you got to go out and test it through observation, measurement, stuff like that. And then once you get all that put together, you make a conclusion, and a conclusion could be either true or false. Okay. This next one, they're talking about these two angles, ABC, DBE. They say they're congruent. Okay, great. And then they conclude that since they're congruent, then they have to be vertical angles. So we learned about vertical angles last chapter. We know that vertical angles are congruent, so I think they're kind of right. But do they have to be vertical to be congruent? And no, I could draw, you know, two different angles that are equal. They're just not going to be vertical. So they show you this picture down here where you got ABC, okay, this right here, and you got DBE, this right here, and they're showing that they're congruent, but are those vertical angles? And they're not. So we're going to say they're not vertical, so therefore the conjecture that congruent angles are always vertical is false. Okay. Last one. Okay. Once again, they're saying we got natural numbers, they're calling it n, and we're going to take a natural number and we're going to go plug it into this little inequality. But since n is on both sides, I got to remember I got to plug it back in. So just to kind of help you out here, they're going to have these choices. They tell you to select all that would apply, and all that apply that make it a counterexample. There's actually one. So I'm going to write each one out. For A, if n is -3, then it would be this. So true or false, is -1/3 less than -3? And that's false. Okay. -3 is actually greater than, or -1/3 is actually greater than -3 because it's closer to 0. Okay. If you take B and you plug this in, you're going to get this. Okay. Well, right here I have a division problem, so that means I got to flip the second fraction, which really gets me to get this. And 1 times 4/1 is actually 4. So now my inequality looks like this. Is 4 less than 4? And it's not, it's equal to, so B would also be false, or make the conjecture false. For C, if I took 1 and I plugged it in for n, I get that, and 1/1 is 1. Is 1 less than 1? And once again, it's not, it's equal to, so C would be false, or make the conjecture false. For D, I take the 5, I plug it in. Is 1/5 less than 5? And yes, it is. Is E, is n is 100, I plug that in. Is 1/100 less than 100? It is. But remember, these three were all making the conjecture false, and I only need one to prove that something's false. Okay, so that's kind of a test question right there. It'd be a good one for you to go take a look at and study over again. Okay. Okay. If a line, last one, if a line segment intersects a segment at its midpoint, so let's do this. Let's draw a line segment, and let's put a midpoint there. So we'll do that. Okay. It says if a line intersects a segment at its midpoint, then the line is perpendicular to the segment. Well, let's see, perpendicular means it's drawn at a right angle, so I think I could draw a right angle through there, but is that the only way I can draw a line through the midpoint? And it's not. I could draw, you know, literally hundreds of them. I can draw it that way, I could draw it this way, I could draw it at different angles. So that conjecture is false, because I could draw a picture to prove that I can draw other lines through it that won't be perpendicular at that midpoint. Okay. All right, so that's it. Hopefully this experiment works. Make sure that you do the assignment. If you have any issues with any of the questions, please make sure you ask. Thank you.